Artificial intelligence, these different areas, so important. And with our concluding speaker, we've got someone who is one of the world's top authorities and specialists in robotics, and the way that robotics is used to make sure that artificial intelligence in robotics works really, really well. We'd like to welcome onto the stage to give you a really interesting understanding about the future of artificial intelligence and robotics. Would you welcome Limor Schweitzer, who is the founder and chairman of RoboSavvy. Limor. Limor, welcome.
So I'm going to talk to you about automation, robotics, and how actually the mobile industry is facilitating a new age of robotics. My company is developing a framework for autonomous robots, and we are very excited about what's about to come in the next few years in terms of robotics and how we will interact with them. So when we think of a robot, we typically think of a Star Wars character, or something from a Boston Dynamics video, or a Sony Asimo, or a Henson's Sophia talking head. But actually we are already surrounded by robots. Anything with a CPU and sensors and a motor can be seen as a robot if it affects our physical surrounding. There are over 100 billion CPUs in circulation, so there's many robots already around us. And we will see more and more of these commercially available robots, or what we think more of as robots. We're already seeing such robots such as vacuum cleaners and window cleaners and pool cleaners, sewage inspection, telepresence robots, hospital robots. These are all currently available. There are a lot of startups, there's a lot of investment in this domain. But robotics and automation have been around for over, some would say 150 years, but let's say in the last 40 years, the evolution of the car industry created the robotic arms. So robotic arms are symbiotic with the car industry. And what is interesting or not in the car industry is that you need to make a product line. You need to make 200,000 units of a car in a given time with no errors. And so the robotic arms were designed for that environment. It's a lot of MTBF, zero error, repeatability. The return on investment model is between a year and 10 years. It's an old market of integration, system integrators, and it's not a one solution fits all. Every project is an integration project. It requires consultancy and a lot of auxiliary work. There are other forms of integration today, other industries. For example, Amazon is very famous for having implemented a lot of automation in their warehouses. They were able to reach 400 million types of items that they're able to deliver now in up to 30 minutes. And that is only thanks to automation. Nobody can beat that. So automation allowed them to reach a point where no other competitor can do the same thing as they do, unless they invest in similar kind of automation. In fact, in their warehouses, everything is automated except the final part, which is the picking. The picker stands there, the shelf will arrive to the picker, he will take an item and put it in a box according to the order, and then close the box. They're trying to figure that part as well. They have something called the Amazon challenge, picking challenge, and every year they have a bounty, and the challenge is quite simple. There are 25 objects on shelves, and the robot needs to pick 12 of them and put them in a box. And the best performance so far has been 85 seconds per item for successful picking. So as long as you've got dexterous hands, you've got job security, at least within the Amazon premises. Another area of automation that has gone through, let's say, hyper-efficiency of automation is farming. Today, most of the milking, cleaning cows, and continuous monitoring of their health is completely automated, as well as in crops, in applying insecticides and harvesting. And we've got today the new age of hydroponics and 3D vegetable growth. This is all automated. Today you've got a handful of people that can produce meat and milk for millions of people. The Western world would starve today without this kind of automation. Now, this, let's call it old world of automation, where you need to do something repeatable 1,000,000 times, is not necessarily the solution for every type of scenario. And more there is appetite for automation, but for other kind of environments. People don't want to think about a 10-year return on investment. They want to think about, I need to varnish this thing in 200 units, and then I need to do something else. And it is a human-intense labor, but maybe a robot can help me. So there is a big appetite for automation everywhere. And in fact, what happened in the last few years, one thing was the Industry 4.0 manifesto, which not many people bothered to read, but there's a lot of conferences about it. It basically says, how does Europe compete with China without having low-cost workers? And the answer, of course, is automation, IoT, a lot of focus on measurement and automating things. And so what China did in response is they created a program called Made in China 2025, where their aim is to have more robots per capita than South Korea, which currently stands at 550 robots. So that's a few million robots by 2025 in China. They've allocated, allegedly, $230 billion as incentive for factories to adopt automation. There have been about 150,000 robotic arms in 2016 deployed in China. So China is really taking a leap forward in automation, surprisingly. And so automation comes in different forms, new automation. It's this, as you see here, this is a factory. This robot is quite inexpensive. It's composed of a mobile robot and a robotic arm. Its price is probably around $35,000. And so it's affordable, and it does a job of moving stuff around within the factory. Other robots are, for example, Starship that does last mile delivery, and others for doing hotel deliveries. These are low-cost robotics that the market is demanding more and more. Now, if we look at what the new automation world will look like, there's going to be two main components. One of them is a robotic arm, and the other one is called an AGV. A robotic arm is what you've seen, in the videos of the car industry, but in recent years, there's been a new age of robotic arms. These are called collaborative robotic arms. So they are so sensitive to the environment that they can work without cages. They can effectively work with humans around without any protection. There was a company called Universal Robots about 6 years ago. They started selling these kinds of robots at a fraction of the cost of the alternative established car industry manufacturers of robotic arms. And they made a killing and eventually had a big exit of $285 million after selling a few thousand of these robots. Over time, there are now about 50 companies making these kinds of robotic arms. There's a huge opportunity. So these are robot arms that work safely among humans. And today you can buy in China you can buy these kind of robotic arms for down to like $12,000. The other component in the new world of automation are AGVs, autonomous guided vehicles. So these are little self-driving cars, autonomous cars that move stuff around. And in fact, the world of pushing carts is huge. Just as a number, Royal Mail has 500,000 carts that are being pushed on a daily basis. This is bound to be replaced by little robots that push carts around. But it's not just pushing carts, it's anything that has wheels. There's a lot of common denominator between any robot that runs around, pushing things around, pulling things around. And this is going to be commoditized. This now is at around $15,000, but inevitably the price will go down to a level where it's a no-brainer to invest in these things and replace any physical labor that requires moving stuff around, either repeatable or non-repeatable stuff. It's quite easy to reconfigure the robot. The components of these robots are being commoditized thanks to the car industry, the lasers, the mobile CPUs, thanks to the mobile industry. I'll talk more about that. And so the commoditization of the components means that the hardware is being dumbed down. Same with the collaborative robot arms. Now I'm making the segue into how this relates to the mobile world. So for robots to operate, they need to know where they are. They need to localize. Imagine in a factory, you've got 100 of these mobile robots moving things around. They need to engage with parcels. They need to engage with payloads. They need to transfer things around, not knock each other off, find the best path. So they need to localize. And there is no perfect solution for localization. There is no perfect GPS, good enough, robust enough for robotics. And there are different algorithms to allow robots to localize. One of them involves what's called visual positioning, or you take the camera, and just like the brain understands the 3D environment, these algorithms allow the computer to understand the environment just by looking at it, just by moving around. Now, it so happens that augmented reality uses the same algorithms in order to place virtual objects within a scene. And because augmented reality is deemed to be the next big thing in us interacting with the digital world, there is a lot of effort all around to transfer these algorithms into hardware, make them very accessible, very cheap. And so eventually the robots, eventually meaning over the next couple of years, robots will benefit from this technology and be able to localize without needing an i7 CPU and tons of battery to compute from video to 3D reconstruction. Another algorithm that is needed by robots is object detection, object recognition. If a mobile robot is walking around and sees an object on the floor, that may be a piece of cardboard that he can step on, or it might be somebody lying on the floor. For that, one of the better solutions is to use artificial neural networks. It just happens that artificial neural networks are necessary also as mobile technology for video annotation, for interaction with augmented reality. And so the robotic world is benefiting as well from developments in mobile technology in order to be able for the robots to interact with the environment. And one more piece of technology, of course, that robots have always been benefiting from is wireless bandwidth, but specifically latency. So latency is essential for robots because it depends on what they do. But if a robot needs to make a decision 10 or 20 times per second regarding interaction with the environment, such as bypassing an object or not banging into things, the robot needs low latency. And And therefore, 5G and the new standards of Wi-Fi, AY and AX, will allow the robots to do things much more efficiently. Hundreds of robots need to interact with each other. Another theory is that maybe the computation can be done in the cloud. Because of the high bandwidth and the low latency, maybe why do the computation on board the robot? Maybe it can be done in the cloud. Either way, I mean, the CPU cycles are just growing, so why not do it on the robot? It doesn't matter in any way. It brings down the cost per robot dramatically. The fact that now there is commodity CPU, there's commodity bandwidth, and low latency. So, just to conclude, this new world of automation, some research looked at particular vertical markets where this would be applicable. These robotic arms, AGVs, and just in looking at cleaning, healthcare, surveillance, delivery, retail, this is a $20 billion opportunity over the next 5 years. And so the new world of automation requires rethinking about reusable components, shorter return on investment, but we're looking at an exponential growth in the automation world, and a lot thanks to you guys, the mobile technology. That's it. Thank you.
So those big robots, the big ones, I thought maybe we could have a video just showing the big robots. Do you have anything like that left in your deck?
Which big robots?
The large robot that looks like Frankenstein.
Oh, yes.
Let's have a look. That's it. That's the one. Can we show that clip?
Can we
show this video clip? No. Maybe not?
Yeah.
Oh, there we are. Yes, well, we'll let that, that's the one. Let that run. And while we're watching your friend there, obviously I can see there's a resemblance. The two of you look quite alike. Just two questions for you, Limor, while we're watching that. Number one, will robots take over everyone's jobs in the mobile industry or in general? And can robots harm humans?
Okay, so taking everybody's job, there was a big study a couple of years ago by McKinsey that got everybody suddenly thinking about the topic of the future of labor. And what they said, they analyzed the US Census of Labor, and they figured out, they took tasks within jobs, not just entire jobs, but tasks. And they noticed that 50% of the tasks within everybody's jobs can and will be replaced within the next 10 years with automation, with today's technology, which means effectively it will be a shorter cycle. So in particular, anything to do with physical labor, so unstructured environment physical labor, there's a 78% chance of that being replaced completely by automation, and so is structure. So that's about future of jobs. So anything to do with physical labor within your job can and will be replaced by automation. There are other things that will be replaced. Of course, data entry and a lot of the data technologies today will be replaced. The other one is about safety. So I often get asked about robotic safety. So the answer is that anything that can be thought of as a potential issue can be engineered into the robot to prevent things from happening. So in an industrial environment or in a home environment or a commercial environment, you can think of every scenario and then either engineer the environment, engineer the robot to prevent from accidents. The challenge really is when you're working in whereas there are a lot of humans and you can't predict what humans do, as we saw in this video. You know, if the humans abuse the robot, then you can't, and you haven't predicted that, then the robot may retaliate one day.
Well, ladies and gentlemen, if you thought robots were just robots, they are not that any longer. Please give a big round of applause to Limor Schweitzer from RoboSavvy. Limor, thank you so much. So, ladies and gentlemen, this brings us to the conclusion of this session, but just before you go, remember this. The phrase artificial intelligence was first spoken and evolved in 1955. 1955. And look how far it's come, and it can only come this way with mobile. Let's go to the final slide, Jeremy. Please, if we would. Just to close this out. There we are. So, ladies and gentlemen, the question for you is, do you have a better understanding of AI and its mobile business use? Thumbs up or thumbs down? What do you say? Thumbs up. Oh yes, Mobile World Congress does it again. Many thanks to Nick Spencer and his team. Many thanks to Jeremy and his team. Ladies and gentlemen, we hope you have a successful show. My name is Ralph Simon. Thank you so much for coming. Nothing about you is artificial. It's all intelligence. Thank you and happy hunting.